Our first example here, we are going to focus just on finding the standard divisor and the standard quotas. To find the standard divisor, we are going to add the populations for all 4 states. $936 plus $27.26 plus $26.03 plus $37.35, and then once we find that sum, we'll divide by the number of things that we're apportioning, so in this case 100 seats. The sum of the numerator is 10,000 divided by 100, and my standard divisor is 100. So now I need to find standard quotas. So to find a standard quota, you're just going to take the population for a state and divide by the standard divisor. So for state A, that's 9.36. For B, that's 27.26. For C, 26.03. And for D, 37.35. We're going to continue to work with this example throughout this video. So using that same example, we're going to use Hamilton's method to apportion the seats. So I'm going to write the quotas up here that we just found. And now what Hamilton does is he finds what's called a minimum quota. And what that is it's just each quota rounded down. So I'm going to take each quota and round down 9, 27, 26, 37. And then to figure out who's going to get the extra seat, because if we add these up, we'll be 1 seat short, he looks at the decimal part that's left. And whoever has the biggest decimal gets the additional seat. So in this case, state A gets the additional seat, 10, 27, 26, 37. So now what we want to do is see if the Alabama paradox occurs if we now have 101 seats to apportion instead of 100. So you have to start by finding a new standard divisor. We know that the sum of all the populations is 10,000, but now we're apportioning 101 seats, and so we get 99. It also means we find new standard quotas, dividing each of the populations by 99. And remember, this is the example that we started with at the beginning. 9.45 for state A, 27.53 for state B, 26.29 for state C, and 37.73 for state D. Then Hamilton finds the minimum quotas, so rounds everything down, 9, 27, 26, 37, and he has to give out 2 extra seats. So looking at who has the biggest decimal, this one, 37.73 does, so we'll round that one up to 38. And then also, because we have to give out 2 seats in this case, 27.53, so that will round up to 28. leaving this one at 9 and 26. And here's where the Alabama paradox occurs, because if we increased the seats, we should not have had a state that went down and lost a seat, and that's what happened to state A. All right, using that same 4-state example, now we're going to use Jefferson's method. Jefferson, he starts off the same way, where he rounds down. But we know from Hamilton's method that when we round down and find that minimum quota, 9, 27, 26, 37, that we won't get all 100 seats. So, Jefferson finds a modified divisor, and then from there he finds new modified quotas. And it's just a trial and error thing. I found a modified divisor. I just moved my standard divisor of 100 down to 98, and I found that that worked. Like I said, it is just trial and error. And then I took each population to find my modified quotas. 936 divided by 98, I got 9.55, and 2726 divided by 98, and I got 27.8, and 2603 divided by 98 is 26.56, and 3735 divided by 98 is 38.11. And so now when I find the minimum and round all those down, I have 9, 27, 26, and 38, and that does add up to be 100. So I've apportioned all the states by using this different divisor. Now, the quota criterion, we want to use Jefferson's method to apportion the 100 seats and find out if the quota criterion is satisfied. All right, so to start with, we need a standard divisor. If I add all these populations together, I'm going to get 10,000, and when I divide by 100, my standard divisor here is going to be 100. And then I also need some standard quotas. So basically divide everything by 100, so 6.8, 16.26, 10.95, and 65.99. So when we truncate those, so round them all down, 6, 16, 10, and 65, we end up with only 97 seats, and we need to give out 100. So I need to increase by 3 seats in order to get up to 100. So I do need a modified divisor. I found the one that will work here again is going to be 98. And I can use that to find some modified quotas and then check to see if the quota criterion is satisfied. So here are my modified quotas. If I take 680 divided by 98, I get 6.94. And 1626 divided by 98 is 16.59. 1095 divided by 98, 11.17. 6599 divided by 98 is 67.34. Round all of those down. And I do, in fact, have now the correct apportionment. What I want to know is Is the quota criterion satisfied? Well, in order for the quota criterion to be satisfied, the number of seats assigned to each state, which is what we have here, should be its standard quota rounded either up or down. So look at the first one. 6.8 rounded down is 6. Okay, that's fine. 16.26 rounded down is 16. 10.95 rounded up is 11. But 65.99 rounded up is only 66, not 67. So that is the problem, and no, the criterion is not satisfied.